Alexander Graham Bell thought you should answer your phone ahoy. Bell may or may not have been the exactly first person to invent the telephone, but he did get a patent for it. The most ridiculous U.S. patent ever awarded is for swinging sideways on a swing. You're not supposed to be able to get a patent for something that's obvious to every expert practitioner in the art. The joke is that the inventor will take your lunch money in lieu of royalties. I'm Professor Mark Hinders, Applied Science Department at William & Mary. This device, which looks like a toy, is a sensor tag. This one's made by Texas Instruments, but a bunch of manufacturers make them now. And they're really quite amazing. It's battery powered, also has Wi-Fi. You can also get them with Bluetooth. But the thing that's most amazing about this that you can't possibly see is that inside of this small device, which costs $30 or $40, is 3-axis accelerometer, 3-axis gyroscope, plus temperature, pressure, and a variety of other sensors. This sort of device, the capability in this device, a few years ago would have been 2 racks of equipment in a laboratory. And so we've been exploring the kinds of things that we can do out and about in the real world with this new technology. So I'd like to tell you about a project that we did just a couple of years ago, developing a system that can accurately monitor wave height. So we use the accelerometers and gyroscopes and devices like this together with machine learning algorithms to determine the motion of whatever such things are attached to. And the particular application here is attaching these devices to oil spill recovery technology, buoys, skimmers, things like that. The problem to solve is that up to a certain wave height, skimmers work really well. If the sea state gets too high, then you have to spray dispersants or some other thing. And so the stakeholders who are coordinating the response to an oil spill would like to attach devices to all the equipment that's being deployed so that they can tell what the sea state is. You also can build these into small semi-disposable buoys that can go out and be deployed and tell what the waves are doing so that you can better direct resources to recover the oil that has been spilled. So we had previously done, through a collaboration, helped develop a mesh network tag system where you put GPS and mesh radio on small tags which communicate with each other over maybe a kilometer distance, and then one in each group has satellite connectivity to connect to, we use Iridium satellites to get full global coverage. So this project, what we did was added this technology to the existing mesh grid tag satellite communication system. So the first thing we did was add this technology to our existing system, and here's a picture you can see of it. It's not particularly exciting to look at because the accelerometer part of it is very small, the inertial measurement unit. And again, the idea of this is to be able to measure the wave height, the sea state. Okay. Once we had begun to build that, we needed to work on the algorithms, and our part of it at William & Mary was primarily algorithms. And so the first thing we did was got some development systems, and then we put together some spring mass contraptions that would mimic wave action, the right period and change the amplitude and whatnot, together with a witness pole. And then at various places around campus, we can excite different amplitudes of wave motion with video, and the witness pole tell what the wave motion was, the wave height, and then we can use that to develop and verify our algorithms. So here's a few video clips you can see of this is Margaret in the video. I think Elizabeth is behind the scenes there, doing some tests on campus with some increasingly complicated contraptions, springs and masses, in order to record data that we could use to develop our algorithms and then verify the algorithms.
Okay. Oh yeah.
once the algorithms are working, then we package things in ways that we could take out into the water. And so we have a lake on campus, so we went there and made some waves and measured the result. We also went to nearby rivers where there are a bit of waves. And then we built a mock-up of the 3-float skimmer that was one of the target technologies. And we took that out by boat to the Albemarle Sound, where we could get a variety of actual wave motion and measure that also with by eye and with the witness pole. And then we also built this into some small buoys that we could go out and deploy and collect data to show that it works out in the semi-open water of the Albemarle Sound. And then the final proof of pudding was to go up to New Jersey to Olmsted, which is a facility that Bessie, the Bureau of Safety and Environmental Enforcement, maintains. And that's a place where oil recovery equipment can be tested. And so we mounted the mesh grid tag radio systems with the accelerometers and algorithms on the actual skimmer devices. We also put some of the technology into a variety of buoys, and then we put them in the wave tank, where you'll see in the next set of videos there were an increasingly large amplitude wave motion, which is well characterized and controlled, and that then allowed us to demonstrate that the system worked as designed. Remember, the mesh grid tag system doesn't just have the accelerometers and whatnot on it. It also has the ability to communicate with other mesh radio systems in the group. But it also then has GPS, so it knows where it is, and one in each group has the satellite tags. And so the proof in the pudding was to have the system measure the wave height that we knew was being generated, collect that information among itself, send that off the satellite, the Iridium satellite, to the system that we had that AECOM had built in to run it with a user interface. And the screenshot that you see here shows the report out from that test, where it has located the device and it has accurately reported back the wave height. So it worked pretty well. Lots of other things that can be done with this amazing new technology and other sorts of things. There'll be some other videos here related to this one that talk about those sorts of research projects. I'm Professor Mark Hinders, Applied Science Department at William & Mary, as.wm.edu. Our partners on this project are Midstream Technology, Avigia Systems, and AECOM. Funding is provided by the Department of Interior, Bureau of Safety and Environmental Enforcement. Many thanks to Karen Stone, the contract monitor.